Good morning, everyone. So let's get started here with today's class. So let me go ahead and share my screen. Okay. All right. So let's just resume where we stopped last time. So if you want to go ahead and launch your RStudio project for the 04 yield monitor exercise, that's the one that we were working last time. Just bring that up here. And oh, and also, I guess just before we get started here, I just wanted to say I did enter your attendance up until I don't think this Monday of this week was included, but everything else up until that point was. So please make sure to go in and check, especially if I didn't, especially if you were not in class, and I'm assuming that if you were not in class, then you did not respond to the GitHub repo for the attendance of that day, then you didn't get your attendance in that case. Of course, if you missed the class, you're not going to get attendance anyways. But please make sure that if I have a absent for you for a given day, but you know that you weren't present, and for some reason I gave an absent, perhaps I didn't see your answer on GitHub, or perhaps you forgot to answer GitHub. Please go through that and make sure that everything that's there reflects your actual attendance. And if it's not, just let me know by email and we can definitely work that out. All right, so getting started with today's exercise, or continuing, I guess, if you already launched your project here, you may be seeing an empty environment because we're just reopening this. And as I have suggested in the past, I do not encourage for you to save your environment from but be in between our sessions for different reasons. So it's always good to have a clean environment when you're starting off. You should be seeing your partial script on top here. If not, again, you can double check you're in the right project by checking the name on top. You click on this R blue button to take you to the home of the project. If you're not seeing the script up here, you can just go on code and I have more things than you do, but you should be seeing your yield 17 wrangling partial there. So just click on that and it will pop up here. All right, so what we can do is, if you have your outline showing up on the right side here, well, if you don't have, you can just toggle on and off by clicking on that outline button. So you can toggle that on and then go to wrangling yield 17W. So that was the last chunk that we did. So I guess just a quick refresher. So we brought in this CSV file, right? So I guess we can walk through quickly here. We brought in a CSV file that had a whole bunch of columns where some of them were needed for us to do the yield data editor part of the exercise, which we're going to be doing after we finish this script. So we basically explore a little bit distribution of yield and also of speed, which are going to be two of the columns that we're going to be filtering after we finish again the wrangling part. We did a little bit of plotting here just to see. We noticed that there was one data point that was very large in yield, possibly biologically unrealistic value. So we did a on-the-go filtering just for visualization purposes. We did not remove this point at this stage yet, but just for visualization, we were able to see the map without that point, which then opens up a little bit more the color scale for us to see differences on other points of the field. We also did a quick scatter plot with a smooth regression line between yield and speed, and we noticed that very high yield points, and most likely unrealistic ones, were happening at very low speeds, and we talk a little bit about that as well. And then we came into the wrangling piece of it, where we clean names first, selected the columns that we wanted to keep, and also did a on the go or on the fly renaming of some columns to include the units. So every time we have columns that are data that contain certain units, it's always useful to have that unit as part of the column name, so it's easy for us to know what we're talking about. We then transformed from English to metric system, both yield and speed. And then really we use three functions here that were new, I guess, for us on the data wrangling pipe workflow. As far as the first one, transforming this, which up until this point was a data frame, we're transforming that into a SF object, which is a vector geospatial type of object, by telling it which were the column names that had the coordinates, right? So point X and point Y were the name of the columns. If the columns were named long lat or XY, that's what we would have said here. However, when we do this, if you recall, at this point here, it is an SF object, but it doesn't know yet what was the coordinate reference system used when this data was recorded. So then we use the st set CRS, and we gave the EPSG value for WGS84, which was the coordinate reference system used when this data was recorded. However, we did want to change that from so WGS84 again is a geographic, so it's in angles, right? It's not in distance. And so we want to change that to something that is in distance, an actual, like even either meter or feet. So we changed that to UTM, which is a projected reference system that now is in the units of meter instead of degrees. And we did that by using the ST transform and assigning or telling it what was the EPSG of the reference system we wanted to transform into, which is 6345 is the one for UTM and the 83 zone 16 north, which is where this field is located. Okay, so I think we stop here. If you want to come to the next chunk, and if you just click on that, like run all chunks above, that should run everything above. And if you didn't have any lingering errors in your code, it should like run smoothly, and you should be able to get EO17W on your environment and also print it down here. So if you just want to make sure that if it worked, you can just go ahead and print that by itself. And if it appears here, then you probably have it to the stage that we're starting today. I guess also before we get started, I also want to note something here. So if you realize the functions that we use that were related to geospatial vector data all started with ST, right? So ST as SF, ST set CRS, and ST transform. So this is the convention for functions coming from the SF objects. That most of them start with ST. So that's a way for you to know you're dealing with this type of object. And also, I did share on my website. Let me just pull that up quickly here to show you. If you did not have a chance to explore, I included. So here's our class website. I included a link for resources. If you go there, there's going to be a whole bunch of links that I put there. And just to show you here, so there's a few cheat sheets for some very cool and important packages that we use. So for example, there's one for SF. If you open that link, it's just a cheat sheet showing a whole bunch of functions and useful functions that this package has. So really, anytime you're working with vector data in R and you're thinking, oh, how can I do whatever? Of course, it's always good to Google, but also check the cheat sheet because it may have a quick answer for you. So I just wanted to show you that. And I also included here other links that you feel free to explore. But there are cheat sheets for ggplot as well, dplyr, and tidyr, which are also very useful resources. So ggplot, again, has a whole bunch of functions for plotting not only geospatial data, but really any type of data. So this cheat sheet's a very nice compilation of some of its most important capabilities. This one here is not opening for some reason. Neither is this. So I'll work on that. But I just wanted to show you some of those cheat sheet links. Okay, let's get back to today's exercise. So if you run up until here, you can just come down to the next chunk. And so what we are going to be, so I left the code, I believe, for you here. So what we're doing is basically starting with yield 17W, again, removing those high outlying points on yield on the go. So we're not saving this filtering yet. It's just on the go. So we can see by the map. We're plugging that into a ggplot call and calling geom_sf. If you recall when we did the NAS exercise, when we were bringing in the county data and as a vector, we always use geom_sf, right? Because that's the geom we use when we're working with SF objects and trying to plot them with ggplot. And then I'm saying that I want the color of the points by the column yield pounds per acre. And I just decreased the size of the point to 0.1. So the default, I think, is 1. So we're doing 0.1 and just changing the scale to Paredes bend. So just to use a colorblind safe scale. So if you run that, this is what it looks like. So if you have taken classes with Dr. George Velides in the past, you may now recognize this field. So this field is a field that Dr. Velides has worked a lot in the past with this producer. And that's basically how we have access to this data. But just so you notice, you can stay here, like you don't have to move up as I'm going to do next. You can stay here, but notice how these two maps look different, right? And this is, again, a feature of ggplot in general. What we're seeing on my screen is because ggplot tries to optimize the space on both X and Y axis independently. However, when we have a map, which is this case here, sorry, let me go back again. In this case here, it's not an SF object yet. So ggplot is just treating as a regular data set, and that's why we see the field distorted. However, when we use geom_sf, ggplot knows now that this is a geospatial data, and it should not let the X and Y axis to just be optimized individually, but it actually keeps the proper shape of that field in this case. So just to notice a difference there. Okay, so this is our first map of yield for this. And again, this is raw yield data. It has not been cleaned yet for this field. Now, the next thing I want to do here is to create so we're going to have a quiz after, but don't get, we have to complete the interactive chunk first before we get to the quiz. So don't get distracted by the quiz right now. But let's just build an interactive plot of this map that we just did above. So I left you a little bit of code where we're starting with yield 17 and then filtering to only have, again, yield values below 3,000 pounds per acre. Let's add a pipe here. And if you recall from the NAS exercise, the function that we use for interactive maps is called map view, coming from the map view package, right? So if we just run this, this is what we get. Not very useful, right? I mean, we have the points there, but they're all colored in the same way. I mean, it's not showing the yield. The color is not by yield, it's just everything the same color. We do see a map. If you zoom out, it is near Colquitt, Georgia, this field here. So we do have the map, kind of helps, but not really. Like, it's not a super useful map yet. So let's make it useful. The first thing I want to do is come under.
Sorry, Professor.
Yes.
Yeah, when I run that one, I get an error saying error in the dar name 2, pass too long.
Can you repeat the error again?
Is error in I think it's directory name, something like that, and then say pass too long.
Okay. So that error by itself, I don't know what's going on. Is anyone else having a similar error? I don't hear anything. Is this Dennis?
Yes.
Hi, Dennis. So let's do this. I think this error is happening on your side for some reason. So let's troubleshoot this after class. I will, for the quiz, this map would have to be developed, but you can either like sit next to another colleague to see when theirs is developed and just look at it and answer on your computer. Um, let's try to do that because I think, right now we may take a little bit of time to troubleshoot this. Is that okay?
Yeah.
Okay, awesome. All right, so the first thing I want to do here is color these points by a variable, and that variable is going to be yielding pounds per acre. So in map view, one of the perhaps downsides of map view is that it doesn't follow the same syntax as ggplot, right? So it has its own syntax. So in ggplot, we will use the AES function. Map view doesn't have that. So in map view lingo, it has an argument called zcol for color of a z variable, which would be, the one you want to color by. So you say zcol equals open and close quotation marks, and say the name of the column that has the variable, which is yield underscore LBAC for pounds per acre. So if we run this, let me show you the code. So now it is actually colored by yield, right? However, what is also happening is a couple of things here. So one is we kind of notice that the outline of the point has a color, which is black, or I think is black, or maybe some type of gray, which is kind of like, especially when we zoom out, it's kind of like making it difficult to see. So to change that, come back to your map view code, add a comma at the end of the pounds per acre, hit return just to break the code. Let's change, so the name of the argument that refers to the size of the point outline is LWD. So we're going to say LWD equals 0 just to see what happens then. Okay, so that basically removed the outline of the point, which is what we wanted. However, even though we now can see better from a distance, the thing is, these points are still kind of too big, like they're overlapping too much. If you zoom in very closely, you can see the individual points, but they're still overlapping too much when we're looking from afar, and I dislike that. So I want to change that. You can come next here, add a comma, hit return, and we're going to use the argument called CEX, which is the one that we change the size of the point, and I want to change that to 0.1. So can you go ahead and run that? Let me show the code. So this is what we get now. We reduce the size of the point, can really see the individual points, right? It's a lot easier to see now when we are zooming out of the field. Another thing I want to change here is, if you notice, the points are a little bit transparent, and I want to change that. I want to make them like fully non-transparent. I don't know if that's the right word, but to do that, so we can add a comma, hit return. So transparency in ggplot, we refer to transparency as alpha. So here it also is a similar idea. So the argument we change is called alpha.regions. I have to say equals. So transparency is a value that ranges from 0 to 1, where 0 is fully transparent, 1 is fully non-transparent or solid. So I want to have it as 1 to have it like fully solid points and not have them be transparent. So if we do that now, I mean, it just changed the transparency again, even though they're small points, but they're solid points. And now I want to show you something that is real. Okay, well, so let me do this. How do I know all, like, how these different arguments are called, right? So one way of knowing this is, well, perhaps the first way that we should explore is using the function help, right? So here in our, every time I'm trying to understand what arguments are available for a function and how can I change them, I say help and then open and close quotation marks and the name of the function. So if I do help map view, which is the function that we're using, we have, it pops here on the side. We can just scroll down to the arguments. So here, right here, arguments, right? So it has a whole bunch of argument names in their description of what they do and what they change. So this is a quick way for you to see like what are the available arguments. And also on the help functions that pop up in R. Normally, if you go to the end of it, there's going to be some examples for you to see how that would be applied to an example. So we can do that. You can always like copy and paste these examples here because they're using data sets that are available for the examples to run. But also, sometimes just looking at the help on our studio may not be the best one. So I would Google, right? So I would Google something like, how do I change the color of points in map view in R, right? So make sure you use the keywords there of what is the issue, what's the function or package that you're trying to find the solution for, and that's in R. Because sometimes these packages have same names across different languages. So if you don't say in R, it may bring you a solution in C++ or Python or something else. I just wanted to give you a quick overview there of how did I find this, all these different arguments and how I was able to change them. Okay, so the last one that I have for you here is the following. So right now, the base map, so the background map that's being shown on map view, I think is coming from a source called Carto, which has this type of map. If you zoom out, you can really see more like, it's a little bit like Waze, perhaps, the way it looks like, even though without all the details of the Waze gives. But it looks like this, right? So it's not a satellite imagery. I guess that's pretty clear. And especially when we're working with precision ag, I think it's nice to have a base map that's at least a satellite imagery if you're working at the field level. When we were working with the NAS data at the state and county level, I mean, we could have also done it, but I guess at that point it doesn't super matter. When you're working within a field, I think that is more helpful to have a satellite imagery. So how do we do that then? So here, I just want to show you quickly on the help. So there is an argument called map types, and there is a list of them that we can change here within map view. So we're going to be changing that argument next. So if you come here, add a comma, and start typing map.types, so it's types plural, we say equal. There's a few different options here that if you wanted to see all of them, we can go to this website right there. And they have specific options, maybe 4 or 5, and you have to type them exactly as they're supposed to be referred to if you want them to work. So for us to change this to a like satellite imagery base map, we would say open and close quotation marks. You can type ESRI just with the E uppercase, so like that. ESRI is again the name of the company that produces ArcMap and ArcPro and all the Arc products. ESRI dot world imagery. So world is W uppercase, and then without a dot, you can just start typing imagery as well with I uppercase. So that's how it should look like. ESRI dot world imagery, where E in ESRI, W in world, and I in imagery are uppercase. So if we run this, look at that. So now we're able to actually have our map on with a satellite imagery base map, which I think is pretty useful. And now I just want to show you here a few tricks that we can do with map view in R as well. So let's say if I wanted to I mean, you know, already know that you can zoom in and zoom out. So this is going to be helpful for you because you can really get close. And as you get close, the points, you can see more of the field behind the points, right? So that's useful. And also, if you just want to completely turn off the yield um, layer, you can just come here on the layers button and just turn it off. So you can toggle that on and off. Okay. Now, besides Dennis, who had the issue with the code, was everyone else able to get to this point? I guess let me ask differently. Was someone not, besides Dennis, was someone not able to get to this point?
Yeah, Professor, I didn't reach the point, but I'm not seeing my map. I think my computer is taking way too long. My code ran
Oh,
successfully, but I still can't see the map.
okay. Yeah, so if you have so every time that you run a chunk and it's still working, a couple ways to know that that's the case is you would see a stop symbol right there on the chunk, which I don't, but you probably are seeing, Omar. And also if you open your console, every time you see the greater than symbol on the console, it means the console is in idle, meaning that it's not working, it's waiting for the next command. If your console is not showing the greater than symbol, it's because it's also still working. That's another way to know that something is going on. And also on the console, you should see a stop sign symbol right here if it is working, like right up here.
I do see the greater than sign, but I don't see the stop symbol anywhere.
Okay. Well, yeah, I mean, as long as I mean, in your case, you know, to really know that the code is still running is probably because of that. Okay, so was anyone else still having issues perhaps in producing the interactive map? So I guess Omar, since you are not in a room with more people, and also Dennis had an issue to produce the map, let's just go through the quiz, and then you can ask me and I can do that on my map and you can see my map so we can answer your question. So here's what I want to do. So the quiz is I'm asking you where in the field do you see low yielding areas? So I just want to tell me, oh, I see this, I don't know, in this area, in that area, in the north, in the west, in the border, in the center, however you can describe it. I want you to tell me where in the field do you see low yielding areas. And again, low yielding for this map here is going to be areas that you see as dark purple because that's what the legend says. And you're going to see some low yielding areas in different places of this field. And I want you to tell me of the areas that you identified being low yielding, which ones do you think can be related to yield monitoring errors and why? One way that you can look at that, and I just want to point something out before I start your timer for the 5 minutes, is you can zoom in, right? Zoom in, zoom out. If you prefer, you can even click on that show a new window pop-up button, which is going to launch the map individually in a different window, and you can really have more space. So if you come in, you know, and you toggle on and off, I just want to toggle off for a moment here, just to tell you a little bit about this field. So what you're seeing now is just the satellite imagery. Does anyone have a guess or a hint of what these like wider parts of the field are?
Those are spots of erosion where it's a flat field. I actually know where it's at. It's just where the water has run and the sand is built up there across the ground.
Perfect. Yes. Was that who was that? Miller?
Yes, sir.
Awesome. Thanks, Miller. Appreciate it. Yes, Miller got it head on. I mean, these are eroded areas where the water flows through them. I think there's a creek somewhere maybe near these trees. I'm not sure, but this is where the water runs and the soil is eroded, and so we have this like more sandy part of the field because of erosion, and that's why it looks wider. And I know that maybe not all of you perhaps can, like, if you don't have the agronomic background, it may be more difficult for you to connect the low yielding values with what we're seeing on the background on the base map. But at least try to come up with some hypothesis. I'm not looking for the correct answer. I'm just trying to make you think, right? So even if you have no clue, still try to come up with a hypothesis. Doesn't matter if it makes perfect sense or not. I'm just trying to make your wheels turn here. So those are eroded areas. And again, you can use the toggle on and off to see where you have low yielding areas. And a hint, it's not only on the eroded areas, so keep that in mind as well. But based on the knowledge that we just shared about these being eroded areas and having more sand, being sandier soils in those areas, but also what you learned through when you read the yield monitor data, or sorry, the yield monitor paper. What you learn about those filters and why those filters are applied, why are they important? Because that may help you also to think about what is going on here and how we can work around that. So, I guess I can, well, I'm gonna give you the 5 minutes, but so Dennis, if you can just sit next to someone else, please do that. And Omar, you can ask me to toggle on and off, and I can do that as well. And if Dennis wants to also use my shared screen for you, also feel free. But then, so what I'm asking you again, if you come down to the quiz, is where in the field do you see the low yielding areas? So this is the first question. You just tell me what parts of the field, as best as you can describe. And of those areas, which ones do you think can be low yielding? The low yielding be related to yield monitoring errors, and why? And just send me your answer by email. Again, here's my email, lmbastos@ej.edu. You have 5 minutes. I'm going to start a timer here so you can also see it on my screen. Omar and Dennis, I think I'm just going to leave my screen with the yield turned off so you can see the base map, because then you can, on your side, if you're able to create this static map, you can kind of look at that and, still have a way of comparing with the base map and thinking about the quiz. We have 50 seconds. All right, time is up. Make sure you send me your email. And again, this is so it's gonna count both as a quiz, but also as your attendance. So make sure you send it, send me right now, and we can keep going then. Okay, I'm gonna continue here. Let's get back. And let's talk a little bit about this. So, I haven't looked at your answers yet. I will look into that and see if perhaps you could come up with something that I wasn't able to come up with. But I just want to discuss some things that we're seeing here and kind of walk you through some of the things we could identify in this field as far as yield errors. So we have, just looking from a zoomed out view, we have low yielding areas on the edges. So we have on this edge here, we have like a strip of low yielding points. If we look all around the edges of the field, we have low yielding areas. We have a low yielding area right here. So this is something that Dr. Velides was telling me that it's a low lying area of the field that gets waterlogged, and so the crop performance there is lower. And you can really see that we can see that on the yield map as well. And then also on these, like we see some lower yielding points wherever we had the eroded areas and where we have a sandier soil. And here's just something interesting to think about is, perhaps that low yielding area was in fact low because it was, a lower yielding area of the field anyways. But also something that happens in this field is, so these eroded areas sometimes can be a little bit of a dip, right? So what happens is as the combine is moving through the field and harvesting, it's harvesting. And then when it gets close to this eroded area, depending how badly it was eroded, it has a dip that the harvester has to slow down and go slowly over it and then continue. So that can also be a source of error in itself because, as you read on the paper, changes like abrupt changes in speed especially can have that effect where it's lots of plant material are being harvested, leading right to the edge of that eroded area, and then it suddenly has to slow down a lot to go over a dip. And then all of a sudden now there's a lot fewer plant material being harvested, and that can have some errors related to the speed change and the speed that the plants are being harvested. So those are just some that I wanted to point out. And again, I haven't looked at your answers yet. I will do that and provide you feedback. And again, there was no wrong or right answer here. I just wanted to get your head thinking about this specific field. Any questions or comments about this or the quiz, or maybe was someone able to think of a different reason that I wasn't?
For aces, I was just thinking of the border effect it might have for the lower L.
Right. Yes. And that's exactly what we see here, right? What was that Kriti?
Yes, sir.
Awesome. Thanks, Kriti. Yeah, so the border effect that we see here, right? So especially I think is very, because the thing is like you would see that a little bit like on the north and south edges. It's a little bit more difficult because that's where like you don't see like an exact line, right? Because it's going perpendicular to like this type of line. It's going north and south. So it's a little bit more difficult to see here, but that's where also where the combine is like turning and just like getting in place to harvest the next row or the next set of rows. So all that maneuvering as well. We also see those low yielding points at the south and north edge of the field, but also here on the side. I think this is a very good example of that, where we have a whole strip here on the edge being lower yielding, which maybe was lower yielding. You know, there could be some truth to that, but it's also probably, you know, it could be that because it's the last pass, maybe I don't know, the plants at the border weren't looking as good. Maybe irrigation there wasn't getting as well to the rest of the field. Maybe it was just not like that pass maybe didn't have all rows being harvested within the swath of the combine, so it had less plants coming in anyways. So different reasons for border effects, but definitely we see border effects all around this field. Okay,
So
yeah, someone had a question?
yeah, Dennis.
Yes, go ahead, Dennis.
Yeah, how do we differentiate low yielding and some of other features? For example, the line on the bound, I think that was maybe not planted, because when you have the farm, sometimes it's like you leave some of the part not planted, like on the borders. So how should we call that one as a low yielding part, or is just like there are grasses or there are like other features which are not plants?
That's a great
Example,
point and great question.
we have seen the sandy areas. Would you call that as a low yielding area, or for me, I thought like the low yielding area, it means there was a plant and that plant did not produce.
Mm-hmm. Yeah, I mean, it could be that you had a plant that yielded like, you know, that didn't yield as much. Maybe it didn't have plants at all, as you're saying. Like, you know, perhaps your planter had I don't know, had a skip or a gap in planting for whatever reason. Maybe you get a clogged planter or whatever it is. You know, maybe you had a row that didn't emerge at all. So that could be a reason. And here's is really interesting, right? Because maybe I mean some of those low yielding areas are probably low yielding like anyways, but some of those low yielding areas are errors, right? So we're gonna be using next some of the um, methods that you all learned on that paper to remove yield points that we believe are erroneous. However, without you going to the field collecting samples, it's really difficult for you to know if that was really an erroneous data point or if that was in fact a low or high yielding area of the field. I guess on the high yield is a little bit easier to see if it's error or not, right? Because as we discussed, we have one point here on this field, which I mean in this map is not showing because we removed that, but we have one point that was like 4,000 pounds of lint per acre, which is not very biologically reasonable, you know, to expect, especially on a farm scale. And so, you know, it's kind of difficult to there's not a good way of saying, okay, this is low because it is actually low or low because there's an error. We can use other pieces of information like speed, for example, to try to catch that. Yeah, but that's a great point.
If I assume like anything below 1,500 is not a crop, will I be right?
So that's kind of what we're going to be doing next based on the paper. However, we're going to be using the data itself to give us a threshold instead of us establishing a somewhat arbitrary threshold. Yeah, so we're going to be doing in the next exercise, and then we, if we can just spin that question, then and I'll be glad to bring that conversation up again, and so we understand what's going on. All right. So any more questions or comments? All right, I don't hear anything, so I'm going to keep going. So then last thing here on this script is for us to, so now we have a wrangled version of this data. So it's being wrangled, and that would be the stage at which for any other type of data, it would have been enough, right? However, with, again, yield monitor data, we have another step, which is the cleaning of the data. So applying some of the filters that you all learned during the paper, the yield editor paper. So for us to do that, I want to do in a different script to not have this script here become too large. Because we're going to be using this data that we produce in this script in a different script, we have to export this data so we can then import on the next script. To export this, so again, yield 17W is an SF object, right? If we export this as CSV, it will only export the data side of it. It will not export the spatial side of it together. So to export as a vector file, meaning as both the geospatial and the data with it, we're going to use the function write_sf to export SF objects. The first argument we give it is a data frame that we want to export. So that's the yield 17W. We add a comma. Now we're going to give it the path, and within the path, we give it the name of the file, right? So open and close quotation marks. As you know, we need to get outside of the code folder. So .. If you hit tab, you are the main folder of the project. Go inside data. So this, I guess we could talk about if we should export this into data or into output. I want to export into data because it's still data. It's still like a process data. And I like to think of output more as like plots and tables. So let's export this into data. I want to call this object yield 17 _ processed. And if you recall, this is where we give it the extension that we want to export as. So you could, don't run what I'm going to show you next, but you could just say .shp and you would export as a shapefile, as an ASRI shapefile. That would be, so just rephrasing that, you can create shapefiles using the write_sf function. And there's other file types we can also create here. I do not want to export as shapefile, mostly because shapefile is going to create 4 or 5 different files along with the SHP, as we already talked about in class. And I just want to avoid that clutter on the folder. So instead of exporting as SHP, I want to delete SHP and I want to export as GeoJSON. So GeoJSON is a open source file type that is for geospatial data, and it only exports one file. And this is also, you can also use GeoJSON files in any GIS, including Arc, ArcMap, QGIS, and others. Also, a quick trick that we learned last semester is, so if I export this now, I just want to run this. So it's giving me a warning here because I already have this file saved from when I was preparing the script. Maybe you didn't get this warning, but I did. And the thing is, if I run this command, this write_sf command here with the same object, it's exporting to the same place and file name, it's going to try to append. So it's not overwriting, it's appending. So each time that I write this, it's going to increase the data size on file. And that is not what we want. And this is unfortunately the default behavior of write_sf. So to avoid that to happen, to make it overwrite instead of append, if you happen to run this twice, we need to change an argument here. So add a comma, and the argument name is delete underscore DSN. So delete underscore DSN. We need to say equals
I think
T.
Dr. Bastos,
Yes.
you're saying only use that delete DSN if there's that warning come up?
No, I'm saying that you should change this on your side.
Okay, because okay.
Yeah, because this warning is telling me basically because it's not letting me overwrite. It's trying to append, and we don't want append to happen on the file. So we want to overwrite. So that's just a quick trick that every time you're exporting SF objects, you want to have that delete DSN equals to true.
Okay, I accidentally ran a little too soon then, I guess.
Yeah, no, that's totally fine. I mean, it shouldn't make it, as long as you have delete DSN true and you run after you included that, you should be good. So just to now double check, if I come here on my files, on my data, you should have now a EO17 process.geojson right there, just to confirm. And this needs to happen again because we're going to be using this same object in the next script.